Imagine standing in equatorial Africa under the sheer intensity of a midday sun. This hot, sun-drenched environment is where modern Homo sapiens first evolved, and it dictated exactly how our bodies had to adapt to survive. This timeline outlines the true starting point of human history. Between 200,000 and 300,000 years ago, every single modern human shared the exact same biological baseline: dark, melanin-rich skin, deeply established through natural selection in these high UV regions. The equatorial sun poses a massive, unseen threat. Its intense ultraviolet radiation penetrates the skin and destroys folate in the bloodstream. Folate is a nutrient absolutely crucial for DNA repair and healthy reproduction. Without it, early human populations simply could not survive. To counter this, human biology developed the ultimate armor. High concentrations of melanin evolved to act as a physical shield, absorbing and scattering that intense incoming radiation to protect the body's fragile folate reserves. There is a common misconception listed on the left, that dark skin evolved to handle hot weather. As the scientific reality clarifies, human cooling relies on sweat glands and blood flow. Dark skin's evolutionary superpower is strictly acting as UV armor, not a thermal regulator. But the human story didn't stay at the equator. Tens of thousands of years ago, human migrations began pushing out of Africa, moving into higher, colder latitudes with significantly less sunlight. As ancient humans walked further north, the biological armor that kept them alive near the equator suddenly became a fatal liability. In the higher latitudes of Europe and Asia, the ambient UV radiation is incredibly weak compared to the blinding light of the African savanna. Looking at the right side of this biological diagram, we see the body's conflicting requirement. Human skin actually needs to absorb a certain amount of UVB radiation to synthesize vitamin D, which is critical for bone health, immunity, and overall survival. This created a severe crisis. The melanin that shielded humans in Africa physically blocked the scarce UVB rays in the north, causing fatal vitamin D deficiencies. As the evolutionary rule explains, human skin must balance blocking intense UV with admitting weak UVB. This matrix maps out how environmental conditions dictate our biology. In the high UV of the equator, high melanin is required to protect folate. But in the low UV of high latitudes, low melanin allows enough light for vitamin D synthesis. To survive the north, the body had to completely invert its strategy. It had to shed its ancestral shield to let the light in. This timeline tracks the depigmentation process. Shedding melanin was a gradual genetic response, driven by point mutations that slowly reduced melanin production over thousands of years. Notice the marker at 8,500 years ago. Ancient DNA evidence confirms that early Europeans actually retained their darker skin for tens of thousands of years post-migration, long before these new genetic variants fully swept through the population. This map highlights a phenomenon called convergent evolution. The human genome actually invented light skins. Isolated groups in Europe and East Asia utilized entirely separate genetic pathways to achieve the exact same biological solution. Very light skin is not a biological default. It isn't a genetic defect either. It is a highly specific, repeatable engineering solution to a severe geographic crisis. This spectrum illustrates the biological reality of modern humans. Skin color is a continuous genetic climb, transitioning gently across global populations based on the UV intensity of their ancestral environments. Modern travel has violently disrupted this ancient map. Today, you can board a plane and cross thousands of years of evolutionary zones in hours. This global map highlights high sunshine zones where modern migration creates severe evolutionary mismatches. When individuals with light, low melanin skin relocate to warm, sun-drenched climates, their ancient biology clashes directly with the modern environment. Looking at the incidence rates here, the clinical cost of that geographic mismatch is staggering. Fair-skinned populations living in high UV environments face incidence rates of melanoma up to 25 times higher than populations with darker skin. However, as these medical illustrations show, melanin is an exceptional shield, but not an absolute one. Darker-skinned populations remain highly vulnerable to a specific, rare variant called acral lentiginous melanoma, or ALM, which occurs on non-sun-exposed areas like the palms and soles of the feet. Because these areas are rarely checked, ALM is notoriously detected late. In 1981, music icon Bob Marley tragically died at the age of 36 from an aggressive form of ALM that originated entirely under his toenail. Today, modern humans of all shades are now navigating environments their ancient bodies were simply never designed for. We have to rely on behavioral interventions, like sunscreen, protective clothing, and vitamin supplements, to manage the gaps in our ancient biology. Whether your ancestors optimized to block a harsh sun or to absorb a weak one, skin color contains no hierarchy. It is a dynamic, brilliant record of human survival, written directly into our biology.